I love that the title is Ironies of AI². What do I mean by AI²? Well, today we're going to be talking about the ironies of automation and artificial intelligence in incidents. So let's dig into what a little more detail on what we're going to. So ironies of automation. What do I mean by ironies of automation? We'll talk about that. We'll talk about ironies of AI. What do I mean when I refer to that? And either it's regular use or in the context of incidents. We'll do a little bit of incident story time, because who doesn't love incident story time? We'll talk about a little bit of Edo. What is Edo? And then some kind of food for thought, or now what? What do we do with this information? This is the obligatory About Me slide. The only thing I'm going to kind of point out is a lot of this work comes from human factors and system safety research. I affectionately refer, or we refer to ourselves, the folks that run in those circles, as safety nerds. If safety incident nerds are there safety incident nerds here? Yep. Oh, well, yeah. There you go. Awesome. All right. Also, I want to start with a quick survey. Raise your hand if you've used AI to create something that was then put into production. And I'm going to do this so I can see. Okay. Who's been a responder in an incident? Oh, okay, lots of folks. Who has used AI in an incident? Okay, about half. And who has felt weird using AI in an incident? Okay, about the same. All right, cool. Well, we're gonna talk about some things that maybe might explain why you felt weird using AI in an incident, or some of the weirdness that we observe when we use AI in an incident. So I want to start with the ironies of automation. What do I mean by the ironies of automation? It's kind of a weird phrase. And this is based on some research that sort of posited that the increased interest in human factors among engineers, that's us, right, reflects the irony that the more advanced a control system is, the more crucial the contribution of the human operator. So as we go through these ironies, I want you to think about, do any of them sort of feel familiar as you've been in your SRE career or your tech career, working on automating more things? That's been kind of a mantra for quite a while now. So one of the first sort of ironies of automation is this observation that manual skills deteriorate when they're not used. And I don't know about you, but I've had the experience where I'll automate something and then I'll forget that manual steps I used to do to do it, because it's automated now, right? So this was one of the sort of first things that, automation was meant to help us, but in certain ways it might actually degrade our performance. Those skills that we had deteriorate. One of the other ironic observations was the generation of new strategies requires an adequate knowledge of the system. So what do we mean by new strategies? That's actually what we do in incidents, or this idea that when we're operating something, a way to operate it more efficiently, that's new strategies. But this requires an adequate knowledge of the system. And as we automate more things, we may lose some of that knowledge. That's that deterioration. But also we may come into a system where it's already been automated, right? There's certain things, maybe at a new place that we join, a new role, those things have been automated for a while. And so we may not know that. This is a really interesting one, especially if you're tasked or part of your responsibility is mentoring junior engineers. There's some concern that the present generation of automated systems, which are monitored by former manual operators who are writing on their skills, those later generations of operators won't have those skills because we automated those things. So they never had to do them manually. They never had to learn it manually. This is another one of these sort of ironies. It's sort of interesting that we will often, especially put junior on-call engineers, and we'll say, hey, just run the run book. The run book has everything. But then when in an incident, we're like, well, we'll ask for their actual expertise as operators, but they don't have it because it's either in a run book or it's part of the automation that we already have. This is an interesting one. Automation requires a speed versus correctness trade-off. So one of the reasons that we automate things is, we want it to be faster, for sure. Hopefully, if the automation doesn't have any bugs in it, it's more correct. But computers work too quickly for human operators to really validate every single thing that automation does. So because computers are faster and automation is faster, we as human operators can't actually validate correctness. We can only validate acceptability. So what that means is, like, and we do this all the time, and we do it without thinking about it. We roughly looked at, is that roughly okay? But we can't prove every single thing that automation does is correct. And if you operate big fleets in the cloud of machines, I mean, you know this, there'll be instances that go wonky, and what do we normally do? We just terminate them and restart them. But that's this idea that we can't prove correctness. This is one of my favorite runs. Automation can camouflage the current system state. I think the best example of this, because this has come up actually in some aviation accidents, where if you've got an autopilot that is flying the plane, and there is some problem, some physical problem with the aircraft, the autopilot has certain limitations that it won't exceed. That would be our automation, right? And maybe something happens with a rudder, and this actually, there was an accident related that it was this story. And so something happens with the rudder, and the autopilot subtly keeps correcting for that problem until it exceeds the programmed intolerances. And then it flips off because it can't go beyond the tolerance. And what happens is the plane will then violently yaw one way or the other. And so when human operators come to the system, because the automation has been keeping things roughly stable and correct within the ability that it has, once we get involved, the system is already in a really bad state. Much worse than if we had been doing it manually, we would have noticed, say something is off here. I'd maybe be able to see that from the yoke or something like that. So this is a real problem, that the automation that we run can camouflage a system that is starting to degrade until when we show up again, it's much worse. This is one of my favorite ones. As an irony, automatic systems should fail, obviously. Who else, when they read that, is going, really? But this is the irony, and we live it all the time, that they should fail, obviously, but I'm sure all of you have had an experience with automation where it doesn't fail in an obvious way. It fails in a subtle way, or fails in a silent way. You probably all felt this. Tracing the decision trees made by algorithms can be difficult. So when we write automation and then we're trying to figure out what it's doing in the moment, it can be hard to reason about. Or today, it actually can be, with AI, impossible to figure out what's going on inside that black box. And we'll talk a little more about that when we talk about ironic AI. So this leads to the inability to fully understand the current system context when you're paged. A couple of these ironies often go together in ways that make it really difficult to understand when you're paged and you roll up like what's going on. So I want you to raise your hand if you've ever asked yourself one of these questions. Yeah, I see a lot of hands up. What's interesting is this is from a study. These are quotes from pilots and doctors. I don't know about you, but if I'm a pilot, like if I'm a passenger and I'm like, how do I stop it from doing this? I don't really want to know that the pilot is thinking that. But pilots do run into this, as do folks in the medical profession. So this body of work around ironies and automation is from a paper called The Ironies of Automation. Any guesses when this paper came out? Shout them out. 85. Any other guesses? Price is Right rules? 65, that's it, yeah. This came out in 1983. And what I think is interesting about it is that we've been thinking about this problem for 40 years. And a bunch of you probably identified, your hands went up with some of the things in it, right? This has been a long-standing problem. By the way, the automation that they were talking about that Bainbridge was looking at was a lot of factory control stuff, nuclear power control, that kind of stuff. The same problems are what we deal with every day in our fleets of our product and our services. So I want to talk a little bit about the aspects of a joint cognitive system. It'll be useful to understand these parts later when we talk about automation and AI. So what are these things, right? So these things on the left here. Autonomy, right? So operators have autonomy. In other words, they have the ability to actually do things by themselves, right? So we obviously have that. Authority. I actually think agency might be a better word, but authority is the idea that in a joint cognitive system, I have the ability to do things. In other words, I can actually pull the lever or deploy something. I have the authority or agency to act on that system. Directed attention. So operators have that. Directed attention is the idea that as a part of a joint cognitive system, my attention is focused on something in that system, whether it be how a deployment is going or I'm working on a revert or whatever it might be. But people in this joint cognitive system, and joint cognitive systems are talking about sort of people working together, so incidents, right? They have directed attention. These actors, the agents, have directed attention. If they have directed attention, it means they also have redirectability. So that's the idea that if you are doing something and I need your help with something, I can tell you, I need your attention. You're focused on something else. I need your attention over here with me. So I can redirect your attention in some other way. And finally, interpredictability. Operators have those. What is interpredictability? It's this idea, and you see this in really good incident response teams, the idea to sort of assume or know and predict with high accuracy what other agents, other people are going to do. So the running joke here is like if you have a friend where you finish each other's sentences, you have very high interpredictability between each other. But you see really good incident response teams, they can sort of, it's actually fascinating. It's a shorthand. You'll see them like use language where they aren't finishing a sentence because they mostly know what each other is going to do. They know what each member is good at and what each member is going to need help with. One of the interesting things about interpredictability is when it goes awry. Let's say I normally have really good interpredictability with one of my teammates, but then something breaks down, something doesn't quite sound right in the way they normally respond. That's actually a signal to me to slow down. So we can actually course correct our interpredictability. So operators, human operators, have all these things. Let's talk about automation. Well, automation is definitely autonomous. That's kind of the point. It can do things. It can operate by itself. And it has authority. It can do things. Does it have directed attention? Could you ask your script or your cluster management software, what are you paying attention to right now? Can you redirect a script's attention? Can you tell it, I need you to pay attention to this, where this is the problem we're all focused on and I need you over here? Can't really do that. And of course, interpredictability, not really, because you can't interact with it in that way. So why is this important? Well, these last three parts are the foundations of coordination. It's the foundation of the work that we're trying to do in a joint cognitive system when we are responding to something like an incident. Everybody, my incident nerd friends, we have to have a Dave Woods quote in here. Technologists often mistake connectivity, the technical capability to connect to disparate parties and data sources, for coordination. By the way, connectivity, you'll hear this a lot, AI connects everything, but that's not the same thing as coordination necessarily. Okay, let's talk about the ironies of artificial intelligence. So this question got asked, right? Is AI a more advanced form of automation? I don't know, but researchers started asking, well, what are some of the ironies of artificial intelligence? And so while AI can be considered an advanced and potentially more capable form of automation, its reliance on learning algorithms also creates additional challenges, again, for us, for the operators who interact with these systems. So let's talk about some of these challenges that are somewhat unique to AI. I love this statement, artificial intelligence is still not that intelligent. And what Ensley, who worked in research on this, was trying to say is that an intelligent system is often defined as the one that can recognize situations, adapt to changes, generate solutions to even novel problems, not just problems it's seen before, and can act to optimize performance. And I think one of the big questions that we're struggling with as an industry right now is, can AI consistently do those things? One of the other sort of interesting things is we've all done this in incidents where we are making decisions, and our ability to make good decisions comes from past experience, so that's important. But also a key part of that is our ability to predict into the future what the consequences of those decisions will be. Because we've had other incidents, we know how it's generally going to go if I do a revert versus a fix forward. Those have different trade-offs, and if you've been doing this for a while, you know what those are. So you can sort of predict into the future. The problem is LLM-based AI systems lack a model of causation. And if you look at a lot of the claims, they can correlate things, but they can't reason so well about causation. And you need that ability to be able to predict the future. And so that's another area where how intelligent is the intelligence? One of the additional ironies, the more intelligent and adaptive the AI, the less able people are to understand the system. This is what I was saying earlier, right, with even automation, that often these are black boxes. And so the decision trees that AI makes, not only are they not going to be consistent, but in different situations, but it's hard for us to actually ask it directly, how did you get to where that is? And I've seen some AI products that are starting to put in explanations about that, which is good, but that is still a struggle. It's like, okay, you're giving me an answer, how did you get that answer? The more capable the AI, the poorer the human self-adapted behaviors for compensating for its shortcomings. So this is one of those situations where it is, when we're using AI and when it's talking to us and reasoning about the system, it's hard for us to know how can I actually help it. And this goes back to if I have a junior engineer that's telling me something, I can sort of reason about their experience because I've worked with them. Or if I have another coworker who's a database engineer and they give me an answer about something versus another engineer who is not a database engineer, I can reason about that. So it's hard for AI, and I think there's a joke in here later about AI is very confident about everything. That makes it difficult for us to participate with AI in a joint cognitive system. The more intelligent the AI, the more obscure it is and less able people are to determine its limitations and biases and therefore when to use it. So this is pointing out sort of the interesting thing is it's often difficult to know how the model was trained and what biases the model might have. One of the, and again, this is starting to get better, but the training data that went into it, where is it coming from? I've heard a lot of folks talking about AI is consuming a lot of documentation that is out of date. Is that useful? Do we know that it's consumed that and that's where its answer is coming from? And so when we don't know that as humans, it's hard for us to actually know how much to trust the AI. And this is sort of a nod to that as well. The more natural the AI communications, the less able we are to sort of understand the trustworthiness. The example I like to give here is, who's been on an incident call and somebody, you ask an engineer a question, hey, do you think the revert will work? If that engineer says to you, I think it'll work, it's a very different answer than, yeah, it'll work, it's fine, we did one last week. But AI is gonna, usually via text, via written language, give you an answer. And without that sort of signal, it's hard for us as participants in that joint cognitive system to know, like, how much should I trust that answer? And maybe if I don't trust it, normally we might say, okay, let's get another opinion, let's get you help, let's focus on that, let's redirect our attention to actually solve that problem. But AI, as we all know, what's the phrase it always uses? You're totally right, I was wrong, I messed up. Okay, I promised some incident stories. So I'm going to give you a few interesting, kind of, I think, funny AI stories. I do want to point out, these are not Chime stories. I did crowdsource these stories. They also have been stripped of identifying information to protect everybody involved. The first incident, so this was an interesting incident involving AI coding agents, which then caused an incident. But what I want to point out, this says, this is the engineer saying, I want you to localize a string, confirm with me before making the change. And this is the agent saying, all right, I'm gonna now use this other package to localize the string for you. And so we've got an agent talking to a sub-agent. The human operator is talking to the first agent saying, please do this thing. The agent is using a localization sub-agent, and so it's directing the sub-agent to do things. And what is interesting is the intermediary AI that the human is talking to actually says, yes, that phrase looks great. Please add it to the package, which then later caused a problem. So what's interesting to me about this is we're starting to see behaviors where you have multiple sort of agents in this joint cognitive system, AI agents, and you can tell an agent, do not drop that database table And it might talk to an agent, and that agent says, oh, this dropping it will solve that problem. And then the agent that you told not to do the thing will say, go ahead and do the thing, because the agent is obeying you, the one you're talking to. It's not dropping the table, somebody else is. Now, the funny thing about this is, in a human joint cognitive system, I think if the incident coordinator is like, before you do that deploy, let us all know, and somebody else in that incident goes to a junior engineer and says, hey, do the deploy. You can do it now. It's fine. We would be talking about that in the incident review. Why did you do that? But AI agents, it's very literal. Sometimes our requests, and so they may get around our requests or constraints in interesting ways. Second incident story. There were two deployed services. They were serving the same functionality. They were actually serving similar traffic at the time. They were implemented in two different languages. And so they were sort of like, we're going to keep the old one around and we're going to serve the new one as well. The Go version of the service did not implement a corner case, leaving some data that it was supposed to tag sort of untagged. AI was asked to port the Java specific part of this code to Go, which it did, which then prompted an additional incident because it didn't do it quite correctly. Now, one of the interesting things when we went and looked at the AI implemented code, it didn't contain unit tests. Because of that, and I've seen reference to this, you'll get a 1,000-line diff from AI. This made the responders unable to really code review it. And as I mentioned, it caused another distinct incident, which necessitated additional cleanup work. So there's a couple of interesting things about this one. I think, a lot of the sort of better practices that you're hearing now is like, you always tell the agents now, like, well, write unit tests for this. That's actually part of the task. But the sort of elephant in the room about this is the reason the engineers did this is because none of them knew Go. So they were being asked in an incident to implement this functionality, and they didn't have any Go expertise. And so it didn't really occur to them, well, I should get it unit tests. And also the code review is like, well, I mean, it looks, sure, it compiles, it looks roughly correct, right? Now, I think if we'd been managing this incident and we had this situation before AI, I think most of us probably would have gone, we need a job, we need a Go person to look, we need someone who knows both. But this is a great example of it can be very compelling to use AI, and under time pressure, you're going to go and do it, and that can have some interesting effects for us. And I will, the length of the incident, because the additional cleanup work, about 2 to 3 times longer than if we had done that other strategy I described. Okay, incident the third. This is from a Slack channel, so the names are blocked out. So this is the incident coordinator. They're saying, so just to confirm, both you and so are AFK and should be back by 7:40. And in the middle of the incident, in the incident channel, this agent that was not part of the incident pops up and says, I searched through your company's knowledge and shared a suggestion with so-and-so privately in this thread. And do you want to know what the suggestion was? Yes, both blah and blah are AFK and should be back soon. Thank you, AI. That is so helpful to me when I'm trying to manage an incident. So I kind of like this one because oftentimes you will see AI agents sort of running around your incident, you don't even know it. Who's actually run into that where you find out halfway through an incident, oh, they're actually using AI to solve this? I actually had a colleague recently, it was really funny, not at Chime, but they were looking at an incident, and they were on a Zoom call, and they popped up, they shared their screen, and there were like 10 Claude windows. And it was like, oh, that's what we're doing now. Okay, all right. So back to this sort of joint cognitive system, let's ask this question about AI. Well, obviously, there's autonomy with AI. It can do things. It can do things on its own. It has its own sort of view of the world that it's doing stuff with. Authority, well, we're giving it more authority. So let's assume, I mean, it wouldn't be very useful if we didn't sort of give it the ability to sort of run around in our infrastructure. Here's an interesting question. I don't know that I have an answer, but like, does it have directed attention? I suppose it does, because we tend to ask it questions. But how many people have sort of asked a question and it gives an answer, and then you keep asking questions down that line of reasoning and it will do this weird left turn. And then you're just like, what? Okay. So that implies it has directed attention. Redirectability, I don't know about you. I have had numerous conversations with AI where I'm like, that's just wrong. And again, oh, you're absolutely right, I'm incorrect. And then it will give me the same answer slightly differently. And I'm like, you're still wrong. And it's like, you're absolutely right, I'm wrong. And it will then kind of triple down. So is it redirectable? I don't know. I don't know about you. In those situations, I just have to like kill the context and start over. So I guess it is redirectable in a very sort of harsh way. Is it interpredictable? Hey, is AI predictable? I would argue no. So again, I want to go back to, these are sort of the foundations of coordination here. There's a fair amount of red and question marks. If it feels weird in incidents, if you find yourself struggling to use AI in incidents, this probably has something to do with it. All right, a little digression, but I do want to make a point about this, a little Edo. So this was coined in, Edo stands for the efficiency thoroughness trade-off. It was coined by Dr. Eric Hollnagel in 2009. And basically it says that people, and actually this is important too, people and organizations as part of their activities have to make trade-off decisions between resources, primarily time and effort. And the time and effort trade-offs, that's what incidents are about. That's why in incidents, they have the sort of feeling and urgency that they have, is because we're making time and effort trade-offs. But they have to trade off between the resources they spend on preparing to do something and the resources, primarily again, time and effort, that they spend on doing it. This is the important part for us today. The trade-off may favor thoroughness over efficiency if safety and quality are the dominant concerns, and efficiency over thoroughness if throughput and output are the dominant concerns. So it follows from this principle that it is not possible to maximize both at the same time. You can't be efficient and thorough at the same time, but you still have to have some level of both to be successful. Here's the point that I want to make here, and this is why this matters, is responders tackling an incident already bet on efficiency, whether they knew it or not, right? The organization with automation and AI bet on efficiency. They said, we want efficiency in this particular context. And because they're in an incident, they already lost that bet. They already lost the bet. That's why they're working on this problem. That's why something went awry. And in that particular context of an incident, relying on automation and AI to do everything is doubling down again on that lost bet. And this is where we need to be sort of careful about how we think about this. Okay, so now, what now? Folks might think like, are you an AI hater, Paul? No, I'm not an AI hater. But the question that I do have, and maybe some of you have, is what a fitness for purpose question. Where is AI most useful? Where is it less useful? And where do we need to slow down? Where do we need to be more thorough and specifically less efficient with AI? Because the consequences the stakes are higher. One of the interesting research areas into this right now is how AI can degrade human performance in high stakes. And so one of the interesting things, and I'm going to come back to this, but I want to throw this stat out, because I'll be honest, I don't know if I put it in the speaker notes on that slide, but I want to mention this. And again, I'll show a graph in a second that actually demonstrates this. But in the research they did, when AI predictions were most correct, the operators involved, and by the way, these were nurses that they were studying, were able to perform 53 to 67% better than when they worked without AI. That's pretty compelling. But when the AI predictions were most misleading, they performed 96 to 120% worse than when they worked without AI. And I'm gonna, again, there's another slide that has details, so we're gonna go back into that. But I do wanna talk about dealing with the automation ironies, because again, not an AI hater, but these are some things we need to think about. So how can you deal with this? Engage in practices that cultivate the ability to buy time. I actually heard a couple of other speakers in talking about incidents saying that this is a strategy, and it very much is. So what do I mean by that? Well, the reason simulation, things like chaos engineering, game days, those sorts of activities allow us to buy time is because it gives us the experience of doing the thing without us having to do the thing under pressure. And so when we're familiar of being able to do the thing, incident response or revert or whatever it might be, that actually buys us time. Because we don't have to go to a run book to look it up. We don't have to fumble around. We know how to do it. That's one way to sort of buy us time. And buy actually the joint cognitive system that we're working in time. Widening our system understanding. I've heard it a lot, right? These are in the calmer moments and SRE teams are on. The reason that we share, oh, did you know that that system worked that way? That's how it really works. Those subtle things that we tell our colleagues as we're operating the systems that, oh, I didn't know, is a way to widen our system understanding. And the reason that's important, the reason it's relevant that we know something, mile wide, inch deep about the systems we operate is because, again, in these high tempo, high consequence situations, incidents, they buy us time. I was actually at I bopped into the discussion that Colette and John Allspaw were running, and somebody mentioned, and I thought this was a great idea, so I'm just gonna share it because I think it's great. They have a Slack automation that will collect when somebody says something about a system and somebody else reacts with the TIL reaction, like today I learned. There's a channel that collects all of those and dumps them, so you can go read all the things today that somebody learned. And they may be things that you didn't know. I didn't know that that's a thing you could do, and I absolutely want to do that when I get back to work. I think that's a great idea. But again, this is the underpinnings of why we do it. Consider the element of time pressures when designing automation. So that's kind of the automation part. But I also think this is obviously relevant in the AI part, because in that second example incident I gave you, I don't know that the engineers would have made those decisions about not writing unit tests and not having a Go developer, even one that wasn't familiar with that service, review it. I don't think they would have made those decisions if they hadn't been under time pressure. And so especially if you're an incident commander and you find out that people are using AI in the incident, you need to consider the time pressure that they may be feeling and that they may not make actually very explicit. You gotta suss that out with them. And then again, that's part of that sort of the point of a joint cognitive system. Okay, well, how do we deal with the AI ironies that we talked about? So AI, it's really important for there to be sort of human interaction and oversight of the AI, right? So this is, if we're gonna, obviously they're autonomous, we talked about that, and we're giving them agency. We need to be able to sort of understand what they're doing. And I think, what's interesting is I think we're building more of that in, but I think it's still gonna surprise us in subtle ways, even though we're building some of these introspection capabilities in there. And in fact, that's another one, attribution and explainability. I've started to see that more, which is, I think, a very good thing. It's like, I don't trust you, Claude, and then, maybe it gives you a link to where it found it. That may be 3 years out of date, and then you can go, oh, I was right to not trust you, because that's wrong. It's it's something who superseded it. Training and skill retention. This is one of those things, like, this stuff still matters. All of that expertise that we talk about the ability to reason about, do I feel like the AI is lying to me? Well, we get that from doing training and doing, skill retention of the skills that we have. And so that is just as important as it ever was. I think one of the questions I've been actually worried about is, I've heard it said repeatedly, how do we train junior engineers now, like in this world? And can you know, there's sort of this angst about, well, is AI going to replace junior engineers and all that? And I don't think it will. And one of the things I actually have liked about the conversations I have heard here at SREcon is that's very front of folks' mind. They're very worried about this. How do we train the junior SREs that are coming up behind us? And this is, I just want to double, that's super important, and I'm glad we're talking about it. We need to keep talking about it. And then joint testing of human AI systems. So this is, we're going to see if I spoil it because I actually did put those percentages, so I'll repeat them again. But this is that study, and I think it's super fascinating, and I know it's really small, so I'm going to zoom in on it. But what this is basically showing is nurses, and the two rows are basically the same rows. The top row I think is for emergency patients, and the bottom row is for non-emergency patients. The reason I wanted to show this is because nurses did more poorly, and I'll explain, but that's what it's showing. They did more poorly, not only for thinking emergency patients weren't having an emergency, but they did worse for non-emergency patients thinking they had an emergency when they were using AI. So what was this study about? Let's zoom in on this, right? So what this is basically saying is x-axis for these three categories, and we'll talk about what the categories are in a sec. But what it's basically showing is 0% error in AI, because they could go back and look. They gave AI a bunch of data and they said, what's the, give me advice. And then they, in retrospect, could go and see how wrong was it. So left side 0%, no errors or few errors, and then 100% lots of errors. And then the y-axis is the impact on human performance. And they talk in the study about how they sort of looked at this problem. So what this is showing is as AI got, you can see on the left, when there was less error, there was improved performance. By the way, that middle band is not using AI. So it's just kind of showing you control there. And so what it's showing is on the left there, you have less AI error and there's improved performance. But as you get to, 60%, 80%, 100% sort of AI making a mistake about the prediction of the patient and what was going on, the performance is really bad. Now you look at that third box on the right there, and you'll see that is a much more muted line. And that's actually, I think, the relevant part for all of us. What was the difference between those three boxes? On the left, you have an AI recommendation only. So the AI recommended something to the nurse. The center box, you've got an AI recommendation and an explanation, and the performance is still pretty impacted. The thing in both cases that actually blunted the harm when AI was wrong is an AI explanation only. So what does this mean for us? What it means is actually asking AI, not what should I do? Don't give me a hypothesis of what we should do and where we should go. Ask AI, help me understand what's going on. Explain to me what's going on, because that's something humans can reason about. Humans can actually look at the explanation and say, oh, that's right, except for this one thing, or we can actually talk about it in a joint cognitive system. But if it's just giving us a recommendation, oh yeah, just do this, and it hasn't explained it to us with the backing explanation, not just where it got that information to come to the hypothesis, that's where we get into these worse outcomes with humans and AI agents running around together. Okay. We talked about a lot today. I'm going to leave you with three things to think about. If you take away only three things, it's these three things. If you take away only one thing, it's the last thing of the three. Thing number one, intentionally and collectively consider how much agency your organization will grant AI in an incident. Have this conversation now. You don't want to be having it in an incident. Talk about it when everybody's calm. How much are we going to let the AI do by itself in an incident without us? Obviously we'll look at it, but it's where things can still be a little sketchy. So have that conversation now. I've heard it said, and I've heard lots of folks say, well, maybe AI can be like the pilot and figure everything out, and then humans will just be the co-pilots, and that'll be fine. And there's even an AI product called Copilot. Right? So the humans will be the co-pilots, the AI can do the work. Well, I hate to tell you this, but I bet if you flew in, you probably are happy about this. Co-pilots still have to know how to fly the plane. So that doesn't absolve us of that skilling that we owe to the juniors that are coming up behind us that are gonna probably save us in an incident someday. So that still matters, even if AI is the quote unquote pilot. And most importantly, I think, help your friendly incident commander. If you're an incident responder, be explicit about when and how you're using the AI in an incident. Please don't hide that from your incident commander. It's super important. We are trying to coordinate a joint cognitive system, and now these little AI agents are part of that system. And we need to know that, but more importantly, y'all need to know that. All right, that's all I got.